latest models.
Sense8.
So those would be like the oldest models.
Yeah, you want the oldest models
Right.
for all their.
You don't want the upgrades.
So here's the thing.
I know this because they saw on regular cycle Cherry and Barbie. Sense8.
Okay, let's look at. We didn't get through part C yesterday. Let's do that. This is pretty tough. I don't know, it's not that bad. Alright, so we got they want us to find the equation of a tangent line to the graph of G. But they tell us that G is x times f of x. Wilmer, you alright?
I'm good.
Alright. That's the sort of behavior that makes me want to get tests.
I'm like,
You might pass out.
do you need water?
It's really hot. Sure, go for it.
Do you need water, Julia? Okay.
Okay. So, tangent line, like your general formula, is going to be y equals blank times x minus blank plus blank. Right?
Right.
Thank you. Oh, okay, I didn't see this. So they give me a point on the original graph. It took me a while to find it. I was like, we don't have enough information. But they give me this point over here. So the x value is 2, and the y value is 6. So I can fill those in. And then this is the hard, well, finding that was hard for me. But this is it's supposed to be the most difficult part, where I need to find what goes in that slot. Slope, which is the derivative, right? Well, the original equation is here. To take the derivative of that, what rule do I need? It's not really a rule, you're just kind of saying things that are on the paper. Wait, say it again. Maybe. I'm not sure if you're trying to say what I want you to say or something different. Something. Not chain.
Multiplication rule.
There's two things with an x being multiplied together, right? So what rule is that?
Additional.
There's two things being multiplied together, so that's addition rule? Is that what
I said multiplication rule.
Product rule. Thank you.
Isn't that kind of like the same thing? Isn't product mean?
I can handle multiplication rule, but at first you said addition rule.
Yeah, I know. I didn't mean
That I didn't like very much. Alright, so you got like your first guy and your second guy up there. Remember your product rule is 2d1 plus 1d2? Remember that?
Yeah.
So the second thing is f of x times what's the derivative of the first thing? 1 plus. First thing is x times what's the derivative of the second thing? F prime. And what I want is to know what the value of all of that is at 2. So I'm going to plug in 2 in place of all of the x's. And then I got to kind of use the graph and the information they gave me to figure out all this stuff. So what's f of 2? 6, they told me that, times 1, plus 2 times, what's f prime of 2? It's negative 1. Do you see where we're getting that from?
Is it from the graph?
I'm just looking at the graph. That graph is f prime. So if I want to know f prime when x is 2, I just read off that graph. So I put a negative 1 there. 6 plus negative 2 is 4. I throw a 4 up there. And there's your answer. Even if you're stuck on this, like if you don't put the 4, but you put everything else, you'll at least get 1 out of 3 on that little part. So even if you don't know the whole problem, just put in what you know. The derivative was the hard part, so it's worth 2 out of the 3 points on this one, but 1 out of 3 is better than 0. Questions on, yeah, Kyle.
So you said that f prime of 2 is negative 2?
I said f prime of 2 is negative 1. And what I'm doing is looking at that point on the original graph. That graph is f prime, right?
Yeah.
So when x is 2, what's the value of f prime is negative 1. With me? Other questions there? Nate?
Where are you getting this? Oh, never mind. I found it.
Yeah, it took me a while to find that also, yeah. It's like hidden in there in the corner. Other questions? Okay, let's go to the next one. Did I assign this one to you guys before or not yet? This is new? Yeah, do you want time then? Yeah, I want you to try it. We'll go through it in like, I don't know, 10 minutes. Make sure you're worrying about like justify your answer also. Don't say the word it, like be clear about F or F prime or positive thing. Just be really careful with your wording. Justification is important. I think it's easy to overlook it, but it matters. Yeah.
So you said the product rule is 2d1 times 1d2.
2 to 1 plus 1.
2d1 plus 1d2. So it'd be 2 times.
So it's the second thing. I mean, the one and the two are like the first thing and the second thing.
Okay.
So it's the second thing. Yeah, second thing. Plus 2 to the first thing. Plus the first thing, which was x, but you already plugged in the 2. Times the 2 and the second thing. Okay. 2 to 1 plus 1. Remember, quotient rule is 2d1 minus 1d2, and then over the bottom squared.
I don't know. I forget stuff.
Okay. Oh, so I review. We'll be okay. my answers up on the screen or not yet? Yeah, I'll put up A and B to start. It's like an energy bar, but it's actually
I can get about 60 of them shake for about the same amount of calories.
sugar.
I just, I would.
That's a sugar replacement.
It seems worse than sugar.
I will be it.
It's like a fake sugar.
I'll just wait.
So yes.
Yeah.
So I'm really confused when you're supposed to like use, because like I said x equals -5, because like it starts there and then it decreases. So how are you supposed to know when it's gonna be a max? The other one, the end point was like
Well,
a maximum.
you're mixing up relative and absolute. Relative max means where does the graph, where does the original graph have like the top of the hill?
Yeah. So why wouldn't that be a negative?
Well, at -5, your slope is negative because you're below the axis. So the original graph is just decreasing at that point. You're mixing up, so the absolute mid, you're kind of mixing up too. So if you look at what's going on with this original graph, it's decreasing here, right? It's increasing like all of this time, and then it decreases a tiny bit at the end. So it goes like down, and then way up, and then back down.
So wouldn't there be a max at -5? Because like that's a max and then it starts decreasing. Because like that was on this problem, like.
Well, but the difference, the other one was that was the highest point of the whole graph. The max is there.
But isn't that still a relative max?
No, because it's not like the top of the hill. It'd have to be like
The other half.
the other half of the hill, yeah.
Because because that's why I didn't pick -1 on the other one. So it can be an absolute max without the other half, but it.
Yes. So for relative max, you're looking for the graph to go from above the axis, the derivative graph to go from above to below the axis, so from positive to negative. So if the derivative is positive, what's that mean the original graph is doing? Increasing. And if the derivative is negative, the original is decreasing, and that's what creates like the top of that hill. Part C is the tougher one. I thought it was tougher than D. You basically need to show them all this. So you have to tell them you're considering the critical points and the endpoints. So critical points are when you cross through the axis on the derivative graph. So the 3, that's a relative max. Then at -4, that's a critical point also. What kind of point is -4 on the original graph?
You get partial credit if you get it right.
What kind of point is -4 on the original graph? It's a relative mid. Now, what's your question, Wilmer?
You get partial credit if you got it right.
Yeah, but like this is a 4 point, I think. You guys have the template for you. This is either worth 3 or 4 points. If you just get the right answer, I think it's just 1. It's 3. So you gotta tell them what points you're considering. Then you kind of walk them through the graph like we did yesterday. So okay, it decreases a little bit, it goes up a bunch, and then it decreases a little bit. At the end, you tell them what the absolute min is. So the absolute min is -4. So just to explain that again, it's because we started off going down a little. Then we increased this whole time, and then we decreased a little bit. So your lowest point is here. And then you got to find what that point is. So then we want g of -4. So there's a couple weird things. Well, there's one weird thing going on here. So I plug -4 in there because it said -3 to x, you know. And I want to know what x is -4. So I plug -4 in there. Well, this is backwards. It's kind of harder to realize because it's negative, but the smaller number is supposed to go on the bottom, right? So when it's backwards, what does that mean? You flip the sign. So I took this step and like explained that. You don't have to, but I was just kind of reminding myself, okay, I'm going to flip those back to where they belong, and then I'm going to put a negative out because that means the sign changed. And then I found the area. So how did I find that it was 1? Where did I get the 1 from? The 1 is the area between -3 and -4, so it's the area of that little triangle there. But because they flipped the direction of the signs, it's not 1, it's negative. That was tough.
What did that solve for?
The 1. So I want I want this. And how do I integrate a graph? Anybody, how do I integrate a graph? I'll go up a level, which is find the area. So I want to find the area. So I'm finding the area between -3 and -4. So it's a triangle with like a height of 2.
You have to write it out, or do you have to write out that calculation, or can you just do it on the graph?
You won't have, I mean, it's like a blue book you get, so you can't write on the graph because you won't have the graph in the blue book. You don't have to show this stuff. I'm not sure what you're asking.
So you have to write the integral from -3 to -4 f of t times d of t equals -1.
You should have the, you might be able to just write that. Is that what you're asking?
You can write g of -4 equals 1.
Yeah, so you can just write the answer. I was just trying to like show my steps.
Is it because it says like the value? Like how do you know you're supposed to get?
Yeah, so let's find the value. So it's not just like where is the minimum, but find the actual value of that minimum. And so I'm plugging -4 in for x into that thingy. Just figure that out. That's very close. And then part D, they didn't ask me to explain it, which was kind of nice. They said, where is there points of inflection? Remember, that happens when the derivative graph has like peaks and valleys. So I'm choosing this -3 here because it's a peak, 1 because it's a valley, and then 2 because it's a peak. For part D. I'm going to part D correct. Okay. Merch. You have a question first.
Wouldn't 0 be kind of just one of those?
No, because we didn't change from going up to going down, or going down to going up. We changed from going down to going down more.
And then I'm pretty sure on a previous one we were supposed to explain, like, you know, it switches from going up to going down and from down
Yeah,
to up. Do we have to do that again on this one?
So they didn't say justify in this one. I think it's because there's 3 and it's just a pain. So you'd have to say like point of inflection at -3 because we switched, the derivative switched from increasing to decreasing. There's another one at 1 because the derivative switched from decreasing. Like it's just a ton to write. I think they were just kind of like having
Okay.
mercy on you.
Yeah.
Any other questions on this guy? And C is tough, and we'll do more of those. So if you're not like fully wrapped around it yet, don't worry. All right, go to the next one. put these up now so you can look at it and kind of process. There's A through C. I can't show them all clearly, but so if you're stuck, you can kind of look at it and process. I'll walk around and you ask questions, whatever. But if you don't want to look at it, don't look.
So that one we have to explain why it doesn't exist.
No, they graded this part. I was just showing you, like that was more for you. Like this is just reminding you. You just said DNE. It's fine. I will. Yeah, because I can't really.
Yeah.
It's really hard right now. I'll talk through C for sure. If you like plug those in, I think you'll kind of see. Like now that you know the answers, plug the answers in. I think you'll kind of see why. So that's wrong there. Okay, before I- Well,
Same thing for the second one, right? You just say x equals 1.
doesn't the second one say justify? Yeah, the second one says explain your reasoning. So you have to.
You have to say there's a g on the derivative graph of g.
That works. Just get in the habit of looking like, do I have to explain this one or do I not?
I have a question. What
Would you like to share the question with us?
what does it mean when it says find the value or state that this does not exist?
Are you on number part A?
Yeah.
So when they ask for G double prime, they're asking you to take the derivative of this graph at -1. That's a quarter. You can't take the derivative at a quarter, so it's DNE. It doesn't exist. So you can't put a value there because that's so that they're giving you that option. Yeah.
I hate to ask this, but I
Nope.
cannot seem to get that
Are you, so you should be finding the area between -1 and -4. So I would split it into like this rectangle is a 2 by 3, so that's 6. It's actually -6 because we're below, but you know what I'm saying. And then this is a triangle that's like 3 by 1. It's like 1/2 based on site, so that's 1.5. And then there's your 7.5.
That's big.
So that's negative because we're below.
Yeah. Alright.
Isn't it? Yeah.
I don't know what I was trying to do.
No, you're right.
I made a stupid mistake and I got negative 10.
That's why we're doing this.
We can like
Yeah. Should I just go now or should I wait some more? Go? Okay. Okay. So part A, if you plug -1 in here, it's asking for the integral from -4 to -1. And how do we integrate a graph? Find the area. So that's what I was doing there. It is below the axis, so it's going to be -7.5. G prime of -1. Well, this graph is G prime. So if you go here, if you start here and take the derivative, that tells you G prime equals F, basically. So this is G prime. So G prime of 1, or G prime of -1, you're just reading this graph. So that's going to be -2. And then G double prime of -1, well, now I got to go down a level. How do I go down a level on a graph? I take the derivative or the slope, but that's a corner. So, like, which slope would you use? And that's where we went into, okay, you can't take the derivative at a corner. So this, the G double prime, is actually DNE. It does not exist. All right. Questions on A? Yeah.
So I'm not getting 7.5
x is 6.
Oh,
Now you're good? Okay. Do I want to know what you put there?
I put a 3. I put a 3 there.
Didn't want to know that.
Divide by 2.
Okay. Everybody else, are we good on part A? Yeah.
Do you have to write the G prime equals F like Russ?
No, that's not like part of the work for that. That's just kind of organizing it for yourself, like so you know you're looking at the derivative graph. Part B, they ask for the point of inflection or points of inflection if there are. So it's that one. X equals 1 is the point of inflection because F or G prime, whichever way you want to say it, changes from a positive slope to a negative slope. Or what's another word for positive slope? Increasing, and what's another word for negative slope? To decreasing. So you can use either one of those phrases. Part C seems to be an issue. It's a confusing question the way that, I don't know, it's just like it's new. But once I show you, I don't think it's that bad. So they give you this, h of x equals x to 3. So let's just call that blank to 3. And what they're saying is what numbers could I put there so that the answer to that integral would be 0.
3.
For example, if I put a 3 there, that's one of the answers. If I integrate from 3 to 3, isn't that going to give me 0? So that's what they're saying. Give me the possibilities, give me the numbers I could insert in that spot that would end up with an integral of 0. Does that right there help some of you?
Yes.
There's 2 more. See if you can find the 2 more. Don't say them out loud. But see if you can, there's 2 more. Like now that I've explained it, maybe that was a little easy. You get 7 and 6. I'm kidding. I probably should not do that. I just like try it. Shut up. There's 2 more. It's not 7 and 6 though. I was just. Oh, that's not helping anything.
Are these right?
No, there's like there's an efficient way.
Mr. Davis, are you helping or hurting?
I know. That's what I was just thinking about. I was hurting. So think about what integrals tell you. Integrals tell you area, right? So 3 to 3, just kind of that's the only one that like that technique applies. You're just going from there, that's gonna be 0. But if I start looking back, like going backwards, I don't know how else to explain it, except just to kind of show you.
You gotta like figure out where the
You got to figure out where they cancel, basically. Yeah. So where the amount above the x's and below is the same. So like at x equals 1, wouldn't these 2 triangles cancel out? And if I put a 1 in here, wouldn't the integral be 0? So x equals 1 is one of your answers. And then where's the other time that would happen? At negative 1, because then those 2 would cancel. Alright? Does that make sense now that I went through it?
Yep.
It's not that bad, but the first time you see it, you're kind of like, whoa, what are they talking about? Yeah. Okay, part D. Part D is rough. I have a feeling. Well, let me ask you this: how many of you put -4 to 0 and 2 to 3? So it's very tempting to put that, but I'll show you why that's backwards. They give me it's like a little trick. Remember, they're trying to screw you guys up. Like that's their job. They're asking where it's decreasing. You have the derivative, so you're at this point like trained. Okay, we'll go about the x's, right? Like that's what we're taught to do. That's kind of what we've done. But this, so we're going from x to 3. Typically, the x is on top. So if you notice, it's always like 3 to x or 0 to x or 2 to x or whatever. So what did they do to the integral? They made it negative. So instead of looking below the axis for decreasing, now what do we have to do? We have to look above. They just flip-flopped the whole thing on us. So instead of, so you have to realize that. And that's the trick. Well, that's part D. They're trying to kick your ass. So I bet 70%, I don't know about 70, but I bet half the people that took this test, whatever year this was, put -4 to 0 and 2 to 3. And like that shows me you have a pretty good idea of what's going on. You just didn't catch that like little trick. Yes.
Okay.
The X is the standard default position of the X on top.
Because there could even be like a 1 there, and when you actually did that, it wouldn't be flipped. Right? But if there was a 1 on the other one, then it would be flipped on the other one.
I do know what you mean. And I can address that, but it's like a 10-minute. I don't want to.
So you're saying whenever you see it on this test, it's gonna, it's
Yeah.
flipped. Okay.
So would have been
So then it's like 0 to 2.
Yeah, so the answer is from 0 to 2. And then it says explain your reasoning, which is not easy either. But I said 0 to 2 since x to 3 is the opposite of 3 to x. That flips us around, and now we're looking above the axis instead of below the axis.
that makes perfect sense.
I mean, so that's another one. Like, I think once I go through it, it's not terrible, but the first time you see it, you're like, what are they even trying to get at? That's why we're doing it. I mean, that's the idea. Hopefully, if we go through enough of these, we'll get through, hopefully, what they decide to put on there this year. You know, that's all we can try to do. All right, go to the next one.
Wait, so
Cool.
that one was weird.
I'm not going anywhere.
Are we supposed to make our own graph on this one?
You are. I love this one. That's a good one.
You said it was a blue book. That says pink test book.
Sorry.
That totally changes the game.
So everything's different now.
Maybe they changed it for 2005. Maybe they changed the color every year. That way you can't read.
That way you can't copy off what color it is.
Yes.
That way they can sell 2 books and get leftovers. Previously, you couldn't use them. You'd be forced to buy new ones. Maybe that's the fact.
Whether you have it.
Like I'm scared. Right. Right. Jeez. I would actually try to draw this first. That's up to you. But that's how your brain works, I guess. Just reading through this sentence in the beginning, the function is twice differentiable except at x equals 2. What does that mean, might be going on at x equals 2?
It's a derivative.
Like a quarter or a cost for something? It's someplace you can't take the derivative of. A cost border, possibly. I didn't put this in the answers. It's not in there, correct? Realize also that I'm going a little fast. Like, you normally get 15 minutes to do these. Trying to get through as many as possible, so I'm not really giving you 15. So you'd have a little more time on the actual test. it still maintains the shape that you get. Yeah.
Does negative second derivative mean negative or down concavity?
Yep. I think I would have said concave down, but down concavity actually sounds cool. Let's start with that. Down concavity. System of down concavity. Yeah, so that'd be like the biggest tip I could give you, I guess. If I'm looking, these are points that go on the graph. And then this is there to tell you the shape. So that means increasing and concave down. If the derivative is positive and the second derivative is negative. Increasing and concave down looks like that. And you're supposed to kind of go through that thought process for each of those sections and then piece it all together. Which I'll do. I'm just waiting for you guys to do it first. Try it first.
So that's what you like recommend doing as A. That's what you recommend starting with B.
I think that's the easiest, yeah. Because I think it's easier to answer part A. Looking at the graph.
If you had this graph for B and then you had stuff written over it just because you were doing more further questions, but they make you mark it down. You know what I mean?
But you might not get credit for that one. So you don't like
I'm just I mean
Like you could write a scratch list yourself there.
so I'd still get credit for B for having the graph
Yeah.
even though there's stuff over it.
Yes. But if you want that stuff to be great, you should. Stuff you like, you know. Alright, I'm gonna go because there's just not a ton of time left. So I'm gonna put those points on the graph first. So I've got a point at 0, negative 1, a point at 1, 0, 2, 2, and 3, 0. And then, like I said, the first derivative positive means increasing, second derivative negative means concave down. So I want to be increasing and concave down to connect those two dots. In the next one, I'm positive and positive, so that's increasing and concave up. In the next one, I'm negative and negative, so that's decreasing and down. And that is where you get that corner. And so, the very first time I did this, I remember freaking out, like, that doesn't make any sense, that doesn't look right, no graph looks like that. But then that's why they tell you this, is that the derivative doesn't exist at that point, because it is, that's like a corner.
Doesn't it's negative but concave up?
I didn't get there yet.
Oh, well you just drew it all. Oh. I thought you did, and I just looked at your graph wrong.
Okay.
My bad.
So no, you're good. I was making sure I didn't screw up. So this would be decreasing and concave up then. Decreasing and concave up looks like this. And they don't really tell you where it's supposed to go, so just kind of trail off, I guess. And then I think it's easier to answer part A once you have the graph, but you can do it either way. There's a relative extrema. So this is the function f, and they want to know when f has a relative extrema. So I don't need to go to any weird levels or anything. I don't need to even take the derivative unless I draw it. So where does that graph that we're looking at have a relative extrema? X equals 2, and what is it? And why?
Slope changes.
So f changes from ink to deke, or instead of ink to deke, what could you say? Positive slope to negative slope. Right. Part C, does that make sense for the graph especially? Like what I'm doing to get those shapes and everything?
Yeah.
Okay. Part C, so now they're saying G is the integral of that graph, which means now they want that graph to represent something different. Now they want it to represent the derivative. What was that? So it was like now they're saying g is the integral of that, which means g prime equals f. So this is now a graph of the derivative that they're talking about. So now, looking at that as the derivative, where are their relative extrema? 1 and 3. X equals 1 is what kind? Relative min. Since g prime changes from neg to pos. And then what else? X equals 3, right? Is relative max. G prime changes pos to neg. Raise your hand if that makes sense to you. Part C. Okay. Part D. Okay. I wasn't trying to like single people out. I was trying to get a general overview. Okay. Are there any questions? So that's a graph of the derivative, right? So it's below the axis, the original is decreasing. It's above the. And so if the original goes from deep to ink, doesn't that create a relative min? Deep to ink. And then if the original goes from ink to deep here.
Good afternoon. I have a quick announcement for you today. There's a GSA meeting in room 8210 after school today. Have a great afternoon.
It is now. In part C, they rephrase it. Okay, now G is the integral of this, which then makes that the
So
derivative.
before it was a graph of normal f,
Yeah.
now they're saying g is
Yeah.
okay.
They kind of change that halfway through. And then the point of inflection, where's the point of inflection? X equals 2. Why? You said it. G prime changes from increasing to decreasing. Yeah. You were fixing it. Sorry. Okay. So is that 2? Is that what you said? Alright. Alright, we'll just keep going tomorrow. Hopefully we'll finish those tomorrow.
So, due to my mother yelling at me,
Is there any way I could increase my grade in this class?
You know, like retakes of time. Or you kind of can't keep on it.
I think so. I can double check.
Well, that's not, there might be one way.
Okay.
Alright.
Alright.
Okay, go back and make any tests too.
Yeah. Kind of figured there was. Oh, I
Yeah. Con, I mean, I don't remember if you did or not, but if you did, that's like very easy way to it doesn't make a huge difference.
Yeah. I don't know. I guess that because my mom yelled at me.
Your mom yelled at you, did you tell you your grades?
She told me to look at it.